So thank you for taking the time to attend this session. Uh, I'm going to talk about data publishing, the data that flows through the state of the art architecture that we have now. Earlier, we started with data warehouses, then we started building the lakes, then we started building the lake houses, merging the data lake and the data warehouse, and now we have Gen AI that we can add to the AI stack. And at Angel, when we are working on to have an AI stack and the processes to build using Gen AI and related AI technologies. Uh, so there are 5 V's of big data, and all of us know about this, that volume, variety, and velocity. These are the 3 things that we have handled through the new architectures, the data lake house, uh, or other architectures that we have, similar architectures. Uh, so but the other 2 V's, the veracity of the data and the value of data, is still questionable. How many of you are able to basically, everybody here should be a data engineer and they should be having a data platform in place. How many of you think that your organization is able to leverage the data to its full potential? If you have built something and you are able to tell stories that is actually driving business decisions, that is actually enhancing the customer experiences, then you have built a great data platform. So the volume of data is increasing at a very high rate. The global volume of data has increased by 5-fold in the last 5 years. So as we have more and more information, organizing it is a very important task. If we don't organize such a huge amount of data, we end up building a system that has information which is difficult to understand. Right? You cannot interpret it. The quality of the data is low. You cannot trust the data to drive business decisions. So there are types of noises in the data. For example, the quality of the data. Right? There are missing data. There are nulls. There are duplicates. Then there are measurements error also. So if you have worked on clickstream, I have personally faced this problem. When clickstream events had future timestamps, and that was, it took us some time to fix it, but these kind of errors are made when we actually start collecting the data. And but data is data, right? The moment you generate the data and you send it outside, right? It leaves the service boundary. The context of the data, right? The time context of the data is gone, right? Any data that leaves a service boundary, it is an information that has happened sometime, and when you receive it, you are looking at the past of some event, right? So again, right, if I look at the noise that we have in the data now, there is semantic noise also. There is disagreement between different departments on the definition of the same metrics. Customer is something for some department and something else for some other department. Another personal, at Angel One, there is something called activation. So Angel One is one of the top fintech firms in India, and we support broking services also. So what happens is, a client has to become trade ready. So there is a business metric called activation when a customer transacts for the first time. So there are multiple definitions for this, right? For example, we struggled for some time whether the first trade is activation or the first three trades is activation. So some departments are tracking first three trades, some departments are tracking the first trade. So this is the semantic noise that we have in the data. Okay, temporal noise, data is coming at different speed from different systems, right? Temporal is, there is one more thing that I want to talk about temporal, and we will talk about it later when we go deeper into the conversation. So structural noise is the schema drift that we have, right? There is a mix-up in the same information. Aggregate information is also there, and granular information is also there. So when you process the data, the numbers are skewed. Now, I talked about noise. The real value of the data is unlocked when we are actually able to make decisions, right? The data, we have encoded the decisions in the data model itself. We should go towards that. When you look at the data and you have the decision, if you want to go deeper and understand why have the system made this decision, then there should be narratives that you can go through and understand how we have reached to a particular score or a particular decision. We'll look into the case studies also, one case study also, where we'll take an example of data narratives. So again, right, the models that we have right now in, say, the medallion architecture that we end up building on the data lake. So the gold layer, we usually end up building the dimensional model. If you have really worked into the model, then it is dimensional model. Otherwise, there are only tables. You just aggregate something, build flat structures, the cardinality is very high, querying performance goes for a toss. All these things happen. But if you have really cared for what you want to do, you must have built a dimensional model and cubes on top of that. But even dimensional model gives you, it facilitates the querying. It is easy to understand and query, but the interpretation, the narrative is still left to the analyst who is using the dimensional model to tell the stories. Right? Data is an afterthought, which means that when we start building a business process, suppose you are building a feature and you are defining a set of steps that the customer has to execute and accomplish a goal. If you don't think about how are you going to measure the effectiveness of this business process, the set of steps that you are designing in the feature, if you don't think when you are designing it, when you are conceiving it, and then what happens is later, at some later time, the team realizes that, oh, we want to measure this particular event also. So then they go and instrument later, after releasing the feature. So what happens is we don't get the full picture, right? Whether the feature is performing better, how can we enhance the overall business process using analytics, right? So this was just one example. Again, since we implement business logic in the gold layer, the business logic is replicated, right? So you have to maintain business logic in the source and in the gold layer. Again, this is an anti-pattern, and anyone who knows about the dry principle, it violates it, right? So what we are going to do is we are going to discuss an approach, and I would like to exchange ideas. What do you think? How can we do it? But I have my opinion, I am sharing it here. So eliminating the noise, we are now going to eliminate the noise, and we are going to build the narrative, right? So basically enhance the data model so that narratives can be supported. So in 2011, I was working with a company that was building a product that they now call a data product. So the company's name was Mobstack, and what they were building, it is now known as Unicode. It is a QR code platform. They are doing pretty well now. So at that time, what they were building is mobile was proliferating, and everyone was accessing content, media content on mobiles. So what happened that all these media houses, right, the Times of India, the Business Line, everybody was trying to create an online presence. And they were not ready for infrastructure that could support mobile devices. So Mobstack created a system that could render the content on a range of like thousands of types of mobile devices. This was our IP. So what they did is they started, so these media houses, they exposed their RSS feeds, and we processed the RSS feeds. We had put together a parallel processing architecture that processed these RSS feeds and saved the information in the data structures that we had defined. now, when I think about it, why did it work at that time, right? And recently, a couple of years ago, data mesh was made popular, and now I think it is quite popular now. There was a huge talk around data mesh, and I was lucky to get a chance to execute a data mesh also. And when I look back at my experience at MobStack, I see that it worked because RSS field was structured, right? The data was mutable, the contract was fixed. Anybody who is reading the RSS content, they will get the same information. Nobody gets a different view of the same information, right? Again, right, there were SLAs. I want to talk about immutability and stable events and the semantic layer. So any data, right, suppose there is an e-commerce system, right, and you order. When you order and write to the read model, when the order is created, you might have two tables if you have normalized it properly. There could be a item table where you have all the items, and there could be a order table, right? You have split the data into two tables. Now imagine that you are replicating these two tables in your data lake, and you are trying to recreate the order create event. What will happen? Do you think the state of order table and order item table will be same when you are trying to join? Right? It won't be same, right? Because tables are coming at different speed. There is eventual consistency. The temporal context of the event is split and lost. This is the temporal content I wanted to discuss in the first slide. So scalability is basically, so that's why first thing is we need proper events that have all the context, right? That's why we talked about fixed contract. We are talking about the SLA, that we know exactly what will be received, what may not be received, and we provision for that, right? Plus the data freshness and all those things are very important when we process the data. Immutability is very important the moment you publish the data, because any secondary service that is consuming from the primary, right, their goal is to build on top of it. They cannot change anything in the data that primary published, because primary, the reality was encapsulated by the primary, right? You cannot go and change it later, right? Because then you will twist the reality of the event when it happened, right? So whenever an event is published outside the primary, it should always be immutable. Nobody should be able to change it. The moment you mutate it, you lose the context, right? The data is corrupted. The second thing is stable events, right? The information, the context that is passed, right, to any event when you publish the event, it should be consistent at later point of time also, right? For example, one of the examples that we can talk about is, for example, so I read it. So this President Bush, right? When we talk about Bush, it was different in 90s and it was different in early 2000s, right? The context, the stability is different, right? So it is very important that the context is passed in such a way that we exactly know what this is. There is no ambiguity in the event, right? The semantic layer is there is a lot of information in the events. You should be able to interpret it. If we leave it to the interpretation of the consumer, everybody will interpret it in a different way. So we need a semantic layer that clearly defines what is the event, what are the different fields, and what do they mean actually. So with that, I have since I have worked on the data mesh also. This is the model we implemented. Okay, what we did is we said that domain events should be published by the service, right? And how do they publish? Using the transactional outbox pattern. Transactional outbox pattern is a design pattern that you can implement on the databases. What it does is when you write to the database, you write to your read model, and you write to the outbox table, and you write the whole event to the outbox table, right? And since we are building the fact tables in our data lake or whatever system we are using for big data processing, we consume this event to create an append-only fact table. So for example, order created can be order table and order item table in the read data model, but there will be a domain event. If you are familiar with domain-driven design, it will be a domain event that will have all the related context, and it will be written to the transactional outbox, and we consume it from there. And we can use CDC or batch processing to tune in the evolving dimensions, basically the slowly changing dimensions. So this is the model that it has worked beautifully for us. So when I talk about the source-oriented data product, the aggregate data product, and the consumer-aggregated and consumer-oriented data product. So what is source-oriented data product? For example, I have a service, right? Order management service. I will have a set of cohesive events that are related to my order, that are relevant to order management service. So I create those events and publish them as a product, as a set on the data platform. This is owned by the domain team. They own this. Now I want to, for example, suppose I have order events in the source oriented. Now I want to know daily orders, weekly orders, the trends and all. Then we go and create aggregate data products, right? Consumer oriented data product is something where we start building the recipes, right? So where we actually join different things and create something that is very specific, right? An example could be that I want to build a data product that can give me intelligence on using, basically intelligence about the user's location and inference that I can draw based on the user location. So basically, location data is used to qualify people, say for loans, right? This could be one of the use cases. So we have to build such narratives in the consumer-oriented data products. So these are the concepts that are taken from the principles of data mesh. So basically what we are doing is we are differentiating between the data on the inside, the data that is used to manage the state of an application, that is data on the inside, the data that is published, right? So that you give commands to other service, and other service might want to build on what you are doing. So then you send these domain events to other services, and they use these immutable events to enhance them and create more value on top of them. So why does this model work? So as the domain, the business logic is encapsulated in the domain. Now data engineering team is not building the domain logic, right? They are just processing, aggregating the data. They are doing what they are good at. Business logic is implemented by people who understand it very well, right? Temporal context, again, since we have all the context when the event is created, when the event was fired, then only it is written to the transactional outbox, and all the correct context is a part of the domain event. So temporal context is also preserved in the event, right? Consistent definition, anybody who is listening to this event, they will get the same information, the interface is consistent. So that's why we reduce a lot of noise that I talked about. For example, the structural noise, right? Now since the interface is consistent and version, we know, right? If we are processing something new, it is a different version of it, right? Different version of the event. Now let us focus on the narrative. So basically the anatomy of a narrative is we see something and then we analyze the situation, we try to find patterns, and then we see a pattern. We diagnose that there is a problem in the system. And based on what we know about the system, based on the decisions that our system can take, we prescribe, okay, now suppose Ravish, his credit profile is good, from his record we can see that he is paying his loans regularly, he has regular income, and all this information is present. And based on some business logic, I can say, okay, now you can give this amount of loan to Ravish at this rate. For you, the rate and amount could be different based on your profile. So usually, when I talked about dimensional model, what it does, it usually describes. We can actually say something has gone. We can add trends to the system. We can say, okay, now something is 5% down. But there is no narrative. It is not related to the overall business process. So what we want to do is we want to build intelligence in the data lake. We want to build higher order layers. For example, add intelligence to the data model and build narratives, right? So what we want to do is we want to add diagnosis, contextual diagnosis and prescription. We want to encapsulate in a data product, and we expose very specific interfaces, the actions a user can take on top of the product, right? Any product that you use, there are interfaces. There is a way you can interact with it. There are call to actions. So similarly, when you expose a data product, we need to be very specific about what can be done, how can you access this data, and how can you use this data. It should be driven. It is not subject to the consumer's interpretation. Again, right, the narratives that we build, they should be up to date based on the changes that are happening in the primary sources. So if we build these three things, we will be able to build a narrative. So again, I talked about personalized lending. FinSecure is a hypothetical company. So the data components that we can build is we can clearly say whether a person is eligible for loan or not, right? What are the loan products that we can show him, right? And how much the rates, basically the specifics of the loans that we can tell them, right? So the thing is, when we say, okay, now Ravish is eligible for loans, a consumer might want to know why. So we have to build a semantic layer on top of this that can give you this information why. And it is not just the catalog. There is metadata, there are visualization, there are workflows, and that story should be woven through. If you want to know why, you want to answer this question for a particular user, that story you should be able to build in the system itself. You should be able to see that. Okay. So basically, look, the thing is, what AI is doing, AI is helping us to predict. The basic job of AI is to predict. Even this Gen AI model, it is just predicting. And the judgment still lies with us. And when the judgments are rule-based, basically they can be encoded, we can always code them up and make a decision. And this is what we have to do in the data products, right? We have to make sure that we know what we are doing, what we want, what type of decisions we will take in a particular situation. And we build that intelligence in the system and encode those decisions so that people who come to the data platform, they directly get the decision, right? Now we are building the narratives. Okay, so the key takeaways are that unless we build the higher order layers and we reduce the noise so that we have data that can be trusted, and we are telling stories, right, that are comprehensible, that people can understand and that can drive business decisions, that can help us improve the product, that is the true value of data, right? Domain ownership is very important because the central team managing the business logic of the whole org is not scalable in companies such as Angel One. Angel One is a medium-sized company. If you go to Walmart or Google or all these, it is not possible, a central team managing everything. Data products building intelligence on top of the gold layers that you already have is the key to unlocking value and basically reducing the time to value. Velocity of data is very important so that you can change your narrative based on what is happening in the source, in the primary, how the user is doing. Is there a new event that affects the loan eligibility? Then it should not be delayed. Otherwise, we will end up disbursing loan to someone who should not get the loan. So yeah, that's all from my side. We have 5 minutes. We can talk.